start. So now it's recording. So I think we can start. By the way, this is like a very informal talks. It's not really about math. I just asked me to give a talk for this summer break, right? So I try to make these talks not technical at all, and well, even more, I just want to make it more or less like a chit chat, okay? Because well, I just want to present something or try to deliver some information or some experience or some story that I have experienced in my last maybe 10 or 15 years. It's about so-called pseudoscience. Yeah, pseudoscience, this word, it might be not so familiar with for you, but I think you can understand it easily by its name, right? The pseudoscience simply means those science, well, those are not really science, but some kind of fake science, okay? And I'll share you some examples, and I will try to do some kind of analysis. To try to analyze what kind of what kind of object or motivation of this kind of pseudoscience create. Okay. So since we are doing math, so since we are doing math, what we first need to do is we need to give a very explicit definition. This is a definition I copied from Wikipedia about pseudoscience. What is pseudoscience? A pseudoscience is just a system or a family of statement or something that sounds like to be scientific and to be true, but actually are not. Okay, actually they are just something that is fake. That is well, some kind of cheat. Okay, there are some examples of the pseudoscience which I will introduce or I will mention in a minute. Which this is well, the first one is astrology, and second one is so-called flat Earth. I think a lot of people heard about this. And third one is also something a lot of people are very familiar with. Is perpetual motion machine. Okay. So talking about this kind of yeah, and I will definitely mention this kind of thing. Well, those so-called in Chinese is so-called non-professional mathematician or non-professional scientist, and I think in English this is so-called a crack. Okay, this kind of person as well, and I will also tell you some kind of this person that I met before, or when I was in undergrad college. By the way, so if you have anything that you would like to share with us, feel free. Just feel free to unmute yourself and say, okay? Because it's not a very long talk for this one. So more or less, I would like to also hear some story of yours. Okay, this is not formal at all, and I hope it will be fun for you. So why this kind of pseudoscience exists? Here, I just try to make some summary, and for me, it seems like there are three kind of reasons why this kind of pseudoscience really exists and why people create this kind of pseudoscience. The first reason is, well, some people are too lazy, and they don't want to think too much. And then, well, in this kind of reason, then some of them build some shortcut to science. And then, well, unfortunately, it becomes a pseudoscience. And another reason is some of them some people are too, well, arrogant, or they are over too self-confident, and in that case, well, they try to trust something which is actually crazy. Okay. And the third reason for people to create this kind of pseudoscience is again very simple. The first two, they may not know what they are doing is pseudoscience, but for the third reason is they know they are doing something fake. They know they are doing something not true, but in order to make some money, they try to create this kind of theory. Okay, and I will talk about this kind of thing one by one. First reason is to create this, well, one kind of pseudoscience is simply because some people are over too lazy, so that they don't want to understand a lot of things about, well, science, about math, so they try to build some kind of shortcut. And this kind of shortcut is easy, very easy to understand, and unfortunately, is not true as well. Here are some examples. For instance, the astrology. I know that a lot of people like this kind of astrology a lot, and I believe, well, most of you know what is the astrological sign, right? I also know mine, okay? Well, and the astrology, for this astrology, for instance, astrology sign, astrological sign, it is very popular, and however, it is pseudoscience. It's not really science, right? Although there are a lot of theory, if you Google it, you can find a lot of theory to discuss what kind of astrological sign can tell you, okay, you are what kind of person, right? For instance, if you are virgin, well, if your astrological sign is virgin, then you must be, you must want to make everything perfect, okay? This kind of astrological sign knowledge is everywhere. However, if you try to imagine, or if you try to think about it, well, it's nothing but kind of a classification of personality, right? It's a very easy classification. In the most basic one, it's just to classify people into 12 cases, right? Well, you have 12 astrological signs, so there are 12 kind of people, and each kind of people are different. So you try to make this kind of classification of peoples, and yeah, it's very easy. Oh yeah. Well, it's very easy, and if you want to understand people, then you don't need to understand person by person. You just need to understand him or her by his birthday, right? And it's really a shortcut. It's really easy for you to understand. Although some kind of advanced version of this astrology or astrological sign is more fancy. However, it's still trying to divide people into something like maybe 100, 144 kind of people, right? But we know that different people are different. We have totally different personality. So this kind of classification is it's really kind of a shortcut. So it's really kind of pseudoscience. It's well, this kind of classification, simple classification of personality is it's not only for this astrological sign, but also in some other kind of literature. For instance, well, this can go back to the ancient Greek, and at that time, I think there is a kind of there is once a kind of theory to say that, okay, people can be described by some kind of, for instance, a blood type. Of course, it's not really the blood type. It's similar things for the body fluid. Try to classify a person by different kind of body fluid. Okay, this kind of thing. So for those kind of thing, it can be shown. It's actually been shown that it's all about the pseudoscience. Okay, and so it's not real. And another kind of thing, another kind of very good example is so-called numerology. I think in some kind of religion, for instance, in this in Tao religions, in Taoism, or in this Christians, or even in the Buddhism, they try to give the numbers some very special meaning. And this kind of meaning is very hard to explain, and you can try to understand it in a lot of ways. For instance, in I think in I'm sorry if this is kind of offense. I just take it as examples. In Tao, and well, he just used 3 as a secret number, and in Christian, I think 6 is a kind of an evil number. And maybe for some of you, 7 is a lucky number for you, and so on. Okay, for this kind of thing, trying to discuss about the numbers and give the numbers some meanings, like this graph. I find it from Google. It gives well, different meanings of different numbers. This kind of thing is so-called numerology. Okay, is you try to say something about the number. You give me the number and then I can tell you something. For instance, even if you gave me your birthday, then I can tell you by doing some algebra of your birthday number, I can tell you something about your life. This kind of thing. It's all about numerology, okay? Unfortunately, this is also kind of pseudoscience. And as an example, I think you can always see this kind of rumor, distributed every day in, for instance, Facebook or Twitter. For instance, you want to say, okay, today something big happens. And something big happens is simply because today we have we can do some operation of today's date, and then you will have some same number of the date, for instance, of 911, and so on. Okay, for instance, today's date is May 14, 2020. Okay, and if you add all the digits of today's date, what you will get is 14. This number is 14. And if you add 1 plus 4, then you will find that, okay, you get number 5. Okay, so today's number we can call number 5. Today is a number 5 day. And if you try to check the same operations or aggregations of 911, September 11, 2001, well, which is a long time ago, I think, for most of you. And if you try to do this kind of operation and see what happens to this date, is 0 plus 9 plus 1 plus 1 plus 2 plus 0 plus 0 plus 1. Then you get 14, and you add 1 plus 4, you get 5 as well. So which means today and 911 are the same type 5 day, okay? So maybe today there will be something huge happen, just like 911. But well, as someone who are doing math, like me or you guys, this kind of thing are totally, well, I should say nonsense, okay? Because you can imagine that we can always do some kind of operations. We have infinite many kind of operations, and we can, well, from this infinite many operations, we can always try to find some connection with arbitrary 2 dates, okay? So you can name 2 days for me, and then I can just let you know what is the relation of them. I can even tell in some very tricky way, or some way that sounds very makes sense. Okay, sounds very reasonable. So this still, well, no matter how you clarify or no matter how you deal with your relation, this is still a numerology. Okay, And whatever it is just some, well, pseudoscience. And you try to, again, classify different dates in some very easy way. And this kind of easy way, there's not even an easy way to explain it. Just like the palm, you try to check your palm, and well, I can always tell you some sense of my palms looks like, and I can always tell you, okay, that tell me the fortune or unfortune of today or in the future. Okay, as long as I know the answer, then I can always tell you something reasonable. It's the same thing happens here for the numerology. And another very interesting example is it's also something that's quite popular, kind of popular in the internet or in nowadays. This is so-called the flat Earth assumption or flat Earth theory. So there are a group of people. Maybe you don't know this, but there exists a group of people nowadays. They claim that the Earth is not a globe. It's actually a flat. It's a plane. Okay, the Earth is flat. It's just like this picture. And believe it or not, on each year they even have an annual meeting. And this annual meeting is actually an international meeting. And well, you know, there are a lot of people. There are a lot of people to take part in this this conference. I forgot. I think this year they have this conference at some maybe North Carolina in US. So you can Google this and you find that amazingly millions of people trust that the Earth is actually a flat. It's not a globe. It's not a ball. Okay. Of course, that makes life much easier because you don't need, if you want to do some math, if you want to study the geography, then it's much easier. It makes life much easier, and you just need to study a 2D plan instead of a 3D globe, a 3D ball. But unfortunately, it's still not true, and we know that it's not true, right? So it's still, well, a pseudoscience. Another very, those examples, some kind of examples mainly on the social science or something not really hard science. And then here I would like to say something, well, about the science, about hard science, physical science, and mathematics, okay? For instance, this is so-called the perpetual motion machine, and for instance, this kind of the Goldbach conjecture or the Riemann hypothesis or some other things that Fermat's last theorems and so on. Okay, and this is something I would like to share you some experience of mine. So this well, for instance, this kind of thing. If you go to Archive, which is a website that you can post your preprint on it without any limitation, without any restriction, and try to Google this kind of keywords about this kind of perpetual motion machine and something like well, Goldbach conjecture or the Riemann hypothesis, and so on, then you will find that every day there are at least hundreds of persons or hundreds of papers, well, in some sense, that have posted on this website. And none of them are, well, most of them are done by someone who are not affiliated with university. Most of them are done by someone so-called the unprofessional or non-professional mathematician or non-professional physicist. And we know that this kind of thing, well, for instance, this perpetual motion machine is definitely cannot be built for sure, right? Because it's it doesn't satisfy, or it's well, valid to this conservation of mass or conservation of energy, or this fundamental laws of the ceremonies, right? So this cannot be built. And however, a lot of persons still say that, okay, this kind of fundamental law of physics, this kind of fundamental law of physics is not faultless. It's, they may have some problems, may have some mistakes, and I just find the mistake. So which is why I build this kind of machine, okay? And this will recently, I think nowadays, in recent 10 years, this kind of machine, this kind of, you can take the motion permanently, this kind of machine is less and less. But I think more and more people claim that they find some mistake from the Einstein's relativity theory. Well, the general relativity, or the, well, or this this kind of quantum mechanics, or this kind of thing. They find some mistake on this theory, and they just say, okay, what kind of mistake they find, and post it online. Okay, so this kind of thing is very popular, or is very common in physics. Meanwhile, it's also very common in math. Okay, it's especially common in this general relativity and the quantum mechanics and the number theory in math, unfortunately. Here, I just want to say that in math, there are a lot of people who claim that they prove the Gödel conjecture. A lot of people claim that they have proved this well, Riemann hypothesis. They claim that they find some mistake on the proof of Well's famous last theorems. They claim that they find some mistake on the on Gödel's proof of this inconsistence of logic system.
Oh, Professor, I think not everyone know what the Riemann hypothesis is. Can you explain it shortly?
It's okay. You don't really need to know what is this hypothesis or what is this conjecture. You just need to know these are just the famous problems, and these problems are easy to understand, and nobody are able to solve it. Okay, especially for this Gödel conjecture. You can see that, well, for instance, I don't want to give this example as as Riemann hypothesis. Maybe I just say what is our Gödel conjecture. You just say that for every even number, it can be written as a summation of two prime numbers. Okay, so it's very easy to understand what's the meaning of this conjecture. Unfortunately, nowadays nobody have even proved that. But since everybody can understand the problems, so there are a lot of people who are interested to really attack this kind of problems and try to give some kind of proof. Okay, and I would say this kind of behavior is is because of they are kind of lazy. It's simply because, well, if they are really interested in math and try to solve some big problem, then why can't they solve some other problems like like the Navier-Stokes equation, like P and NP problem? Well, actually, P and NP problem is also a lot of there are a lot of proved paper in this area, or some kind of KM theory and so on. Okay, some other unknown theory. Why don't they interested in this kind of theory, but instead they are interested in number theory and in the conjectures or in number theory? Well, the reason is very simple. It's simply because it's the only thing they can understand, right? And it's the only thing that is unsolvable but understandable for them, which is why they try to solve it and hope that they are lucky enough so that they find some other way that nobody have even imagined how to solve it, and then eventually solve it. Well, what I would say is this kind of people, although they work very, very, very hard on this kind of problem, at least seem to be, and they write a lot of thing on this kind of thing, but I would still say this kind of person, lazy person. Why is that? It's just like nowadays, well, there are a lot of people, still a lot of people who want to go to, for instance, who want to be a movie star or who want to be a TV star. And so they try to take part in some kind of shows and try to sing some songs and try to dance and so on, and try to do this kind of thing and want to become famous, okay? And why a lot of people want to become famous in this way? It's simply because it's very easy, okay? Maybe if you are lucky enough, maybe, well, today you are not so famous, but tomorrow you are a famous star and everybody knows you. That happens in the, well, in the area of movie or in the area of media, which is why a lot of people want to get in this way and want to take part in this kind of exams and try to compete with others in this area, because it's very easy to get into the bar and try to reach some level of, for instance, of this will try to behave good or try to sing better and then become a star. Okay, you'll find that the difference between you and this kind of movie star is not as far as the difference between you and a scientist or a mathematician. It's very easy for you to do this. And you can even do that, you can even become famous in one night. Okay? So same thing happens for those unprofessional mathematicians or unprofessional physics. They don't really want to be a mathematician or physicist because, well, they just want to get some free lunch and want to get some shortcuts, want to get, well, I'm sorry, it's kind of over too noisy. Maybe I can find somewhere. I'm sorry.
Oh, also, I think sometimes that like even famous mathematicians like do that, because I think it was like
exactly
2 years ago when Michael Atiyah claimed that he solved the Riemann hypothesis, right?
Yeah,
and he was like such a famous mathematician.
Yeah, it's another problem. I'll mention that in a minute. But I think for those unprofessional mathematicians or this non-professional physicists, what they want to do is they want to be famous without complete their PhD, without doing a lot of research on literature. Okay, and of course, if you want to say that, of course, they do have chance to be correct. Well, statistically, they do have some very small chance to be correct, but well, you know, statistically, if you are a monkey and you are in front of a typewriter, you will still be able to, and you try to type it, you'll still be able to write the whole Shakespeare, right? So this is quite common, and actually, based on the quantum mechanics, you know that, based on the quantum mechanics, you know that, maybe you don't know that, I will tell you, based on the quantum mechanics, actually every person has a very, very small but positive, well, probability to transport. For instance, transport from my apartment to your apartment. Although this sounds like impossible, but based on the quantum mechanics, this is still possible. Although the probability of this kind of thing happens is just like 1 over zillions, okay? So if we try to, if you try to, based on nothing and try to prove this kind of famous conjecture, then it's just like, well, it's just like what? It's just like, suppose long time ago, when we are in this, well, maybe 1,000 years ago, maybe 10,000 years ago, we are both kind of apes, or we are both kind of monkeys, or at least not very talented at that moment. And then suddenly you see a bird just fly on the sky, okay? And then you think that, okay, since a bird can fly on the sky, then why can't I fly on the sky? So you make your mind, 10,000 years ago, you make your mind, okay, I would like to build a flight or an airplane to make me fly on the sky. Then you starting from nothing, and then you try to make some metal, and you try to make all the accessories, you try to make all the screws by yourself, and eventually you make a whole airplane. And then this whole airplane take you to the sky, and you can fly now, okay? So to me, those people who claim that they prove those kind of famous conjecture is just like, an Asian people, build an airplane by themselves, okay? So if you do not have any tools, if you do not have any literature, or if you're not an expert in this area, you may be able to prove something, but with very, very low probability, okay? And here I'll give you more examples to say that even some very famous people can make this kind of mistake and can claim that they really show some kind of thing that is very important, but eventually they are doing some pseudoscience. For instance, this first person, his name is Luc Montagnier. He's a French, and he's a French, and he is actually a very famous biologist. And he's actually he's actually a Nobel medalist in 2008, I think. But after he got this field medalist, he turns out to become trust of one kind of pseudoscience, which is so-called the memory of water, which claims that the water can somehow release some kind of microwave, and then it can somehow affect all the other kind of thing. Okay, this is for sure a kind of pseudoscience. And another example is Linus Pauling. He's also a very famous chemist. He's a very famous chemist, and he's also a Nobel medalist. I think he even got a Nobel medalist twice. Okay, and I think he passed away in 1994 something. And unfortunately, after he got the field medal, he also tried to concentrate on something turns out to be false, and it's actually a pseudoscience, which is he tried to study a large amount of vitamin C. He trusted that a large amount of vitamin C can actually cure every kind of disease, okay? Which of course is kind of a pseudoscience. And so you can see that not only for those very non-professional guys, if you are not a guy that is a professional in such area, even you are just a biologist and you try to study the water and or chemistry, this kind of thing, then you may make some kind of mistake. Which is why I'm saying that, okay, do not try to trust those kind of non-professional mathematicians or physicists. And moreover, I think do not trust, do not respect with their effort, okay? Because what they really want to do is they just want to find some shortcut. And another very good example, although this may be arguable, is, this guy is actually a very famous mathematician in Kazakhstan. You know, so he's a fellow of the Academy of Science in Kazakhstan. So he's a big guy, okay? I think it's Professor Otolobov. I don't know how to pronounce his name correct, okay? And I think a couple years ago, 5 years ago, he claimed that he proved the Navier-Stokes equation, which is, well, one of the biggest problems in math. And actually it's the biggest problem in my area. Okay, and eventually he claimed that he proved that. So there are a lot of things, a lot of discussion after he released his preprint. He claimed that he proved this Navier-Stokes equation have a solution and so on, this kind of thing. And well, I have a big I'm very impressed about this kind of thing simply because I'm still at that moment, I think I'm still a PhD student, and well, my advisor is a famous mathematician, and he's in this area. So at that time, when I see his preprint, this Professor Otto, well, his preprint, I have a meeting the day after that with my advisor, and then I ask my advisor, so, well, what does that mean? If he really proved that, does that mean that, okay, we will lose our job? Because then we don't have the biggest problem. We don't have a big problem. We don't even have any motivation to study all kind of things. And we will have the bankrupt of this area, right? Then, well, my advisor just to say that, okay, so, well, you know, I cannot say anything about this. Well, for some reason, well, someone just refer his paper to me, okay, to my advisor, because he's an expert in this area, and he's also a Russian, so he know Russian, okay, so he can read Russian. So at that moment, he is one of the good person to read this kind of preprint. And then he said that, okay, so I just I don't really want to read it, so I just pass it to someone who have a higher position and maybe more prepared, maybe more appropriate to read this paper. And after, like, I think a couple of weeks, Terry Stahl, who is also a very famous mathematician in UCLA, and one of the reasons why he's very famous is, well, he knows almost everything. Well, he knows a lot of things, actually, not almost everything, but a lot of things. And another reason is Terry Stahl is very handsome. Well, so he's kind of a star. He posted a blog and say that, okay, I actually proved one theory about the energy estimate of a Navier-Stokes equation, and which can show that for Navier-Stokes equation, if you don't have any breakthrough in physics side, okay? If you only try to do some energy estimate for this differential equation itself, then you cannot get any positive result, okay? And then, well, eventually, Terry Stahl's paper published in James, Journal of AMS, which is one of the best journal in mathematics. And his paper, well, his paper is not cannot be seen as a reply to the paper by Octoboff, but can be seen as a reply to a family of this kind of paper, which says that if you try to prove Navier-Stokes does have a solution, then you must get some better, some kind of better idea, not an old idea. Okay, and so which means at that moment we feel really happy because at least if someone claim that they proved the Navier-Stokes equation, we can say that, okay, you don't really prove that because you don't get rid of this mathematical analysis. You don't really go to the physical view or the physical viewpoint of this equation. So you must be wrong. So his paper is really great in the sense that we don't need to worry too much about the non-professional mathematician in our area in some sense. At least a huge family of this kind of paper we don't need to worry about. Well, this is very interesting things, and also there is another incident that I've seen Well, when I was in summer school in Stanford, I think in about 8 years ago, in 2012. At that moment, it's a conference. It's a well, Otto Bov is he's a very famous mathematician in Kazakhstan, but he's not really in our area. But now, at that moment in Stanford summer school, it is actually a summer school in our area, in our very small community. Okay, and at that moment, well, there is one professor. Well, I couldn't tell you his name because this is kind of embarrassing. This is I will not tell you his name. And he is actually an expert in the relevant area. And well, by the way, this paper is this preprint published in 2016. And the thing I mentioned now in Stanford is it happens on 2012. So at that moment, there's no Tao's paper. So at that moment, this professor gives a series of talks, 3 talks. And he gave the 3 talks, but the first 2 talks he gave sound very annoying and very easy in some sense, okay? And eventually, at the 3rd talk, at the end of the 3rd talk, at that moment, I almost fall asleep. He gave the talk and it was noon and I almost fall asleep. But then he eventually claimed that, well, he proved the Navier-Stokes equation, okay? He didn't really say that, but he said that, okay, so based on this method, we can prove something in 4D, some other case in 4D, and he didn't say that on his slides, and he said that, and we can actually use a similar method to show the Navier-Stokes equation does not have a solution in 2D, in 3D. Well, I was almost fall asleep at that moment, and but when he say that, I can see that everybody around me, just suddenly will suddenly stand up, will almost stand up and try to concentrate on him. Eventually, it was the end of his talk, and eventually, after his talk is a Q&A session. It's a Q&A after everybody's talk. So he just asks anybody have any questions. Then at that moment, everybody has staring. Well, one guy. This guy is Peter Constantine. He's a leader in my area. He's also the postdoc mentor of my PhD advisor. He's the biggest guy among us, okay? So everybody try to look at him and try to ask him a question and say this is wrong. But this is, at that moment it's so embarrassing. So hopefully, well, the good thing is Peter Constantine, he didn't really ask any questions, and then that's the end of his talk. And a couple of years later, when we met him again, and he gave another talk, and he never mentioned this kind of thing again, okay? So you can see that even in this area, even an expert in this area, they may make some kind of mistake. They may make some kind of mistake in this kind of big problems. If they don't concentrate on these problems a lot, well, if they just think that they may solve this problem, okay? Another example, and this might be an arguable example, is Shinichi Mochizuki, okay? He wrote a huge paper about the ABC conjecture, I think about 5 or maybe 8 years ago. And this paper is about 500 pages. And he claims that he proved the ABC conjecture. But by using some universal triangle series and this kind of thing. But since his paper is over too long, so nobody will really be able to understand it totally, because he tried to build everything by his language. If you haven't learned algebra, then you don't know how hard it is to try to understand this whole system of language. So basically, after a couple years, nobody really understands the whole system of this kind of language. However, he still claims that he proved the ABC conjecture. But based on the most recent news that I can hear, well, ABC conjecture is a conjecture. It's more or less like a generalized Fermat's theorem, Fermat's last theorems. Okay, so it's a big conjecture in the number theory. And well, I'm not in this area, but I also read some news about this kind of proof. And eventually, it turns out, well, this guy, the Shinichi Mochizuki, is also a very famous mathematician in Japan. Okay, he's, I think he's a professor in University of Tokyo or some research institute of University of Tokyo. So he's very famous, and he did a very good job in a lot of sense. But then it turns out most of the mathematicians, well, they think that he didn't really prove the ABC conjecture, okay? And I think the reason given by Terrestrial, well, it's Terrestrial again, because Terrestrial is very, he knows this kind of, well, I don't really need to know what is ABC conjecture, okay? I also forgot what is really ABC conjecture. It doesn't matter. Terrestrial is really an expert in number theory and PD, and this time, and also combinatorials. So he is an expert to deal with those non-professional mathematicians or these cranks. Okay, so Terrestrial is very he tried to convince us that he actually, well, actually he didn't give us a very good proof about well, this ABC conjecture. It's simply because based on his paper recently in the last 5 years, no other output based on his theory or based on his paper. So which means if his theory is totally correct, okay, if his theory is totally correct, then there must be some kind of byproduct by his language or by his theory. But well, after 5 years, nobody really do this kind of thing. Nobody really get this kind of theory. So they think that he eventually didn't really prove this. He didn't really prove the ABC conjecture. So you can see that. Mm-hmm.
By the way, talking about Terence Tao, do you think that his results on Colas conjecture are true? Because he didn't claim to solve the entire Colas conjecture, but he said that he almost did it. So well,
it almost did it doesn't mean anything in math, you know. Well, you may not know, but you will know that almost did that means an epsilon distance. That means a huge gap. Okay, in most of the cases, unfortunately.
Yeah, but the thing is that if his partial results are true, they're true for a big bunch of numbers you start with. So
yes.
it means a big development. But do you think his results are true?
Well, I don't know. I'm not expert in this area, so I cannot say anything about this. So we have to wait for the experts say something. Okay, we cannot really say anything. Well, for instance, about this ABC conjecture, but we can trust those mathematicians who are expert in this area. Okay. So I think the reason why people always have this kind of mistake, one reason is, well, they are quite lazy. And another reason is, well, they may have some kind of stereotype. They may have some stereotype of mathematician or scientist. Okay, and these stereotypes we will, well, I don't know. I actually don't know. But Terrestrial is kind of a promising guy. So, well, if nobody say he's wrong, then probably he's right. Okay. Well, I think, well, lazy is one of the reasons why, well, we can see a lot of this non-expert or non-professional mathematician or cranks. Another reason might be there are a lot of stereotypes about mathematician and scientists. And these stereotypes are made by this kind of media. Okay, for instance, you can see this comic here, which is, well, you can also see that outside of my office, which is how this journalist or the reporter translate a scientist, well, what scientist says about their result to public, okay? It's totally different story. And another, well, good example is, well, this is a very famous movie, A Beautiful Mind. It's about John Nash. Well, unfortunately, he passed away, I think 2 years ago. And in Princeton, he was working in Princeton, and this movie is based on his story. Okay. But it makes this kind of stereotypes a lot, because on this movie, a mathematician becomes an insane person, okay? And he has he's antisocial, and kind of a weird guy, a weirdo, and a very nerd guy, okay? And this kind of stereotypes, it happens a lot in the media, in the newspaper, in the movie, in this kind of TV, and the publics always think that the scientist and the mathematician are always like this kind of person. So which means if you can meet this kind of person who is antisocial and maybe very weird and try to study by himself and try to do a lot of works by himself, then he might be really doing some math. Unfortunately, this is not true. And it's not true for anybody who tries to do math in this way, and it's not true for a mathematician, okay? I don't know whether you know this or not, but well, maybe you can see that, at least in our university, you can see that scientist or mathematician, we are also social person. If you are not as genius as, well, you are not really a top genius, then you must be very social, okay, in order to survive in academia. Otherwise, it will be really hard for you to survive and get a job in academia. You have to be very talkative in order to teach students. You must be very talkative. You must be very social in order to communicate with others, okay? Nowadays, science and math is not something like you can do it by yourself, okay? You have to do it by communication with others. This is also why nowadays we need more and more fundings, because we need to travel to talk with everybody else. And another, well, example is this is why the Gödel conjecture is so famous in China. It's simply because there is a very famous, famous author. He wrote a book about Gödel conjecture. He wrote this book actually not only by about the Gödel conjecture, also about Chen Jingrun Chen, who is well, in some sense, my academic uncle. Okay, because my algebra teacher is actually has the same advisor with him, with Chen Jingrun, and so I kind of know this. So after this Xu Chi published this literature about the Gödel conjecture, the Chinese academic of science every day got hundreds of letters claim that, okay, please read my paper. I prove the Gödel conjecture. And well, this is actually quite crazy and quite, quite insane in some sense, okay? And even nowadays, I think 10 years ago when I was undergrad, I take part in this ICCM, which is the International Congress for Chinese Mathematicians at that time. And in that congress or in that conference, I was a volunteer, and at that time, I see a lot of well, maybe not a lot of, but I really see several non-professional mathematicians. They try to, for instance, in the Q&A sessions of a talk, they say that, okay, maybe could I say something about my proof of the Gödel conjecture or Riemann hypothesis? I can say that in one word. I can say that in 1 minute. And this kind of thing. I really see this kind of thing. Well, this is really crazy. And at that moment, I even got a book. I even got a book, well, which is one person. He tried to very small books. He tried to distribute his books to us at that moment, and well, everybody got this kind of books, very small books, and he claims that well, Gödel has some mistake in his proof of his inconsistent proof of a logical system. Well. But eventually, it turns out that, well, me and my classmate try to read it and find that the way he tried to prove it is he assumed Gödel proved from this step to another step, and then he built a middle step. Say that, okay, from this step to this step, he must go through this step in the middle step, intermediate step, and this intermediate step is wrong. But Gödel doesn't prove it in that way, okay? So in most of this kind of papers done by non-expert mathematicians, they always have some kind of logic mistake. It's always this kind of logic mistake, unfortunately. Which is why, well, I encourage you to try to maybe learn some set theory, or at least to try to learn as much as math course, so that you will not make this kind of math mistake, and you will at least be able to tell, okay, on the first step or the second step, you made a mistake for this kind of thing. But I would say, in general, please don't, please just ignore this kind of person, because they always make mistake, and you don't need to waste your time. Okay. By the way, that expert, well, that person, that crank that distribute his book, eventually he's kind of famous crank in around my university, because my algebra teacher my algebra professor actually know him, and he's actually a rich man. He's a businessman, and after he retired, he kind of becomes interested about this kind of thing. So he is okay, but unfortunately for those kind of crank, most of them are not very rich. Okay, well, so this is something about the lazy. Okay, well, for those people who are lazy, and they may try to do this kind of thing, this kind of bad thing. Okay. And another thing is, well, is something I would say is arrogant. I think it's arrogant. Okay, and this kind of pseudoscience is, well, it's trying to connect the science or the scientific fact with some political things. Okay, with something about the social science. Okay, it's they claim that something may not be wrong. It's just an opinion. Okay. For instance, well, nowadays, recently actually, or maybe recent years, in US, there are a lot of people who try to claim that they don't want the vacuum, the vaccine. Okay, this is anti-vax. This kind of motion or action is so-called the anti-vax. They claim that they don't want to have this this kind of vacuum to their child or to their kids, and they want to have this kind of freedom not mandatory. Okay, because they assume that they are not helpful, or at least some of this kind of thing are not really helpful for them, or that can even be toxic. Okay. And another example is, well, if you are interested in this kind of like 4chan or this Reddit, this kind of forums in US, you may see that somebody who really interested in this kind of T4 hat. Okay, what does that mean? Well, this is a very interesting thing because they think that the tin foils can somehow help their brain. Okay, can somehow to avoid from their brain to some kind of microwaves or some kind of waves or something. Okay, and so they try to protect their brain by this T4 hat. This sounds very stupid, okay? This sounds really stupid, but it's there are a lot of people, maybe thousands, maybe even millions of people who trust the government are trying to do some brainwash, no matter what government is, they try to do some brainwash to them, okay? So they try to wear this kind of hat in some kind of, even some big conference. If you go to Amazon and search this kind of T4 hat, you will find a lot of things. Okay, you can buy them easily in Amazon. And another example is this kind of so-called Indiana pie bill. Although it's almost over 120 years. Although it's, I think it's this bill, it passed in 1897. Okay, it's a bill say that in Indiana state in U.S. It's a bill passed by Senate, and it claims that, well, someone claimed that he gets this patent and he want to give it for free to public. We just need to pass this bill. The government should just pass this bill, which claims that pi should equals to 3.2. And it almost passed by the Senate in Indiana state. Every senator, all the senator agree with this bill. Okay, not even one disagree with that. So this is really a disaster, and hopefully at that time there is a professor at Purdue and then gives a talk to the senators. Although at the first talk they still don't convinced, and most of them still want to pass this bill, but will eventually, based on some public mediums, and eventually this bill doesn't pass. Okay, so unfortunately, this kind of thing is still, well, it's still, there are some person who still trust them. This kind of thing, well, pi equals to 3.2, this kind of thing is something happens 120 years ago. So it may not be so popular at this moment. But still, I think I would like to share you this, this video so that I think it might tell you some, well, some of my point. I think this is a very interesting video. Unfortunately, I don't find the English version, but they speak English, so I think you can understand it. This is a very short video. It's like less than 10 minutes.
Oh, Professor, I don't think we hear like the sound of the video.
Oh, you don't hear the sound? Then how can
Yep.
I listen? Okay, maybe I should do it this way. Maybe some of you have watched this before. Okay, it's very famous. This is well, this is a very famous video. Can you hear it now?
Yes.
Okay.
We're here to learn. And we learn from mistakes. Everybody makes mistakes. Nuh-uh.
But I think
Look at this question.
it really makes my
What
point.
is 2 plus 2? See, you wrote 22. But when we do addition, we don't just put the numbers next to each other. That's stupid. All right. Now think about it this way. If I have 2 markers in this hand, and then I add the 2 markers from this hand, how many markers do I have now? 22. No, Danny, it's 4. Mrs. Wells, we're Danny's parents. Oh, yes, hello. Oh, please come in. Now, don't worry. It is completely normal for kids to get frustrated when they're struggling with a subject. So, what's this about Danny getting some answers wrong on this so-called test of yours? We had a test. One of the questions was, what is 2 plus 2? Danny answered 22. And that's not the right answer, says who? Says math. She's right. She's right. Thank you. Nazi Germany. You can't honestly tell me that you don't know what 2 plus 2 equals.
I think your audio got like really bad.
Well, although I haven't seen this kind of situation in my career, but I really understand, well, this kind of thing may be happening, yeah, nowadays.
Did anybody hear anything?
You don't see the video. Wait. You cannot see this video?
Oh no, I'm just like writing what happens because I think people cannot hear the audio and some people don't know Chinese characters, so I'm just like roughly
Okay. Well, can you hear it now? I mean, I assume you should be able to hear. Can you hear it now? Terrible. Why is that? That better? I'm sorry, I clicked something wrong. So you still cannot hear it? If you still cannot hear it, well, it's okay. You can just Google this alternative mass, okay? And you can see that. Okay. So,
Can someone translate the last sentence hook from Chinese? Because I cannot do it like precisely.
well, basically, if you don't really get it, it's fine. And how about you just Google it? And I think this this short movie just to make my point. Okay, this short movie is so-called Alternative Mass, and you can watch it by yourself. It's very interesting, I think. Although I cannot say that this kind of thing really happens, but I would say, well, this kind of thing could happen, okay, especially nowadays. So this is what I'm saying. If you think that, let me try to change it. Can you hear me? So this is actually what I want to say. That is, if you are too proud of yourself and so that you're even proud about your mistake, then I don't think this is something good. Okay. Well, I'm out of time, so I'll just say a few about this last part, which is well, another reason why people would like to create this kind of pseudoscience, okay, and why this pseudoscience becomes popular. Well, another reason is they try to make money. This is very sad, but it's actually happened, unfortunately. And for instance, a very good example is, well, in US, there is something so-called pyramid power, which is, well, some people, they believe that the pyramid have some secret power, and so that it can give them some kind of magnetic field and keep them healthy, okay? So there are a lot of people, if you try to check it from Amazon, there are a lot of people trying to sell this kind of pyramid, well, small pyramid model or something to people, okay, and say that this is good for your health. And another example is it's a book published in Japan and also in China. The name is Water Knows the Answers. Okay, in that book, this author claims that if you say something to the water, and then you can see different kind of crystal structure of the water. For instance, if you say, okay, the water, you are so beautiful, then it will show this kind of structure, okay? If you say, okay, you are really annoying, then the water may have this kind of structure, microstructure. Well, this is a kind of, and based on this book, this author earned a lot of money, and also he sell a lot of his kind of bottled water. His company of bottled water sells a lot of, get a lot of money, okay? So you can see that some people, some badass, they really try to cheat you or try to fool you by this kind of pseudoscience, okay? And another very interesting example is, well, this is a story. I don't really see this kind of thing, but I think this kind of story, they could happen. I think this kind of story could happen, which is a kind of a spam email, okay? Maybe there is a series of soccer games that happens now, and on the first match, you may got an email say that before the first match, you may got an email say that, oh, I'm anonymous, and dear sir, I hire some kind of mathematicians, and they build some kind of algorithm which can predict the result of this match. The result is A team will win, okay? And tonight you find that, okay, A team wins. You think that, oh, maybe that's a coincidence, it's okay. And the second day, the second match, you got another email. Before the second match, you got another email. Okay, our model says that on the second match, the B team will win. And then you find that the result of the second match is, okay, B team wins. Maybe it's another coincidence. Okay, so you ignore that email again. And on the third day, you got the same email say that, okay, our model shows that Team C will win tonight. And then you find that on the third match, Team C wins. Then you see that, okay, maybe they really build some good model to predict the match, the result, right? And then on the fourth day, they send you the email. They send an email say that, okay, if you want to know the further result, just send money to this account, and I will tell you the further result. And probably you will see, you will trust them that, okay, they may really got some insider, or they may really get some good model, math model to do the prediction. And then you may send them money, okay? But the fact is, well, this kind of badass, they just do something very easy. Okay, what do? They just do like choosing 4,000 of people, 4,000 of email address, and send half of them say A team will win, and half of them say the opponent of team A will win on the first day. And on the second day, on those 2,000 email who got the email, 2,000 email address who got the email say that team A will win. He divided into two parts. Half of them say team B will win, and half of them say the opponent of team B will win. Okay, and then they got another 1,000 email address who still gets the correct answer. On the third day, they do the same thing and got 500 email address, and so that they do the correct prediction, right? And eventually they send this kind of this kind of money links and ask them to send their money. Then they probably will trust it, right? So this kind of thing, do the prediction, is still kind of a pseudoscience, but they just try to use it very smartly. Okay. So in summary, very short summary, well, what should you do if you face to this kind of something seems to be true, but not really, this kind of pseudoscience? Well, here are things that I think we should do as a well-educated person, okay, to face to this pseudoscience. The first thing is you should trust experts, okay, in this area. This is very important. Of course, non-expert may got some correct answer or correct point, but expert will have a better chance to get it correctly, okay? And the second thing is, you have to remember this, there is no shortcut. There is no shortcut to anything. This is especially true for math, okay? If you want to solve some big problems, some big math problems, you have to do a lot of preparation, which is why whenever you try to face to a research project, the first thing you have to do is you do a lot of literature study, okay? You try to see what other people's are known, okay? You try to see what other people's are done. Believe it or not, well, you may not know how smart Gauss or Euler are, okay? You may not know how those great mathematicians, how great they are, okay? They are really great. They are really genius. And it's very hard to find some missing point from their paper. It's very hard to get some blind point, some blind area from their observation. So there is no shortcut. You have to study it step by step, okay? And also do not, well, at least try not be proud of making a scientific mistake. It's okay to make mistake. That's totally fine. Everybody make mistake. You can see that. Even expert, even big mathematician, they made mistake. But please make sure that you are not proud of it, okay? And if it is about science, it has to be either right or wrong, okay? Maybe I'm not a good person to say this because I'm an analyst, and in analysis, of course, you can bound a function by 100, or you can also bound a function by 200. But if you bound a function by 1 million, then you might be wrong, okay? This is my point. So in math, maybe the result, the mathematical result, may not get you a correct answer or may not get you precisely what's the answer you like, but it will get the correct skill. For instance, everybody eats 3 meals a day, okay? But this may not be true because somebody may eat 5 meals a day. This is fine, right? So if we say everybody eats 3 meals, then you can argue, okay, maybe no. Maybe for me, I'm doing some, I try to keep my feet, so I eat five times a day. But this is okay. But if you claim that this is totally wrong, I can claim that there are some guys who eat 100 times a day. Then this might not be true, okay? And the last thing is, well, there is no free lunch. Again, there is no shortcut, there is no free lunch. So if you really find some something like miraculously something happens, like something amazingly happens, then maybe there will be some trap. Okay, there might be something wrong behind it. So that's basically all my talks. Sorry for run over time. So yeah, if you are interested, we can discuss about this kind of thing. And well, if you are interested, you can also try to share some story of yours. I believe you also have met this kind of things before. If you haven't, then that's totally fine. You can hear some story from others, okay? But that's all my story. Okay, so it's your time now.
Hey, that was such a I like the story about how you were nearly sleeping on the lecture until that guy said that he did the strokes too. I think there were like
Stop recording first.